Okay. All right. So let's just go through, for example, some of the material very quickly here. So we began with the software requirements engineering process. Can you remind me what is the process? There's four main phases in the process. Okay. First of which we said it's requirements elicitation, right? Followed by, let me see, the guys at home are following. No, not specification, just a little early. Requirements analysis, okay? And then followed by specification, okay? And we said that those two tend to happen alongside each other. And then finally, we have requirements validation, okay? And before all of this, we do something called the feasibility study, okay? Feasibility study needs to be short, quick. So we make a decision, either we go and start or we don't go. Elicitation is where we gather as much information as we can. Okay, we need to plan for it, prepare for it. There's different techniques for elicitation. We looked at ethnography. Okay, we looked at surveys, and we looked at surveys / questionnaires. Actually, same thing. Questionnaires, and also interviews. Okay, and we said that one tends to follow the other one. Like we begin with ethnography, then we realize, so we start to build a picture. We still got some big holes here that we fix a lot of these holes with the surveys. Realize we got some specific information that we need to get, so we do the interviews. In case the system that we're dealing with is a new system, a pioneering system that's never done before, okay, then we might do a brainstorming session, okay. So this is the requirements, the elicitation, and the different techniques under the elicitation approach, okay, elicitation process. And then we said we looked at analysis and specification, but actually before that, I forgot one area. We looked at setting the scope, very important, okay? And in setting the scope, usually the trick is, obviously we want to understand what's going to be in, what's going to be out. We're going to list the set of features, and we looked at the requirements engineering pyramid, okay? We said we have needs, and usually in the needs, we have 0% solution, just 1%, 100% problem. Okay, so this is solution problem. And then we decided to create some features. Okay, and the features are supposed to be, we're there to adhere to the needs and realize the needs. Okay, and when we start to talk about features, now some of the solutions start to sneak in. Now we're constraining the design space a little bit. Okay, the design space is supposed to be at the very bottom. Here is where we have the design. Okay, and we said that the problem domain, the requirements engineering domain, is where we're just talking the problem, but in reality, it's not 100% like this. Okay, ultimately, when you actually do talk about just the features, you're already restricting some. And then we talked about the requirements specifications, the most detailed one. And the specifications, again, they need to be tied to the actual features. A little later on the course, we'll take something called requirements management, and we'll be able to build something called traceability matrices. And those traceability matrices are very important, even in practice. One of the most important things that you deal with in practice, that you actually are connected, so that when you know you've done some change, that change could have been in the need. طبعا highly unlikely that you're actually going to be needing to change the actual need. Okay, then you'll need to see which features were affected, and you need to see which requirement specifications are actually affected, and vice versa. If you actually change a specification, you need to see which feature got affected and which need got affected as well. It might not be a bad thing, but nonetheless, we need to be aware of what we're doing, okay? We need to make sure that what this is that we're going to be giving to our design team to actually create an implementation of, had we changed it, what is it affecting? We realize that some specifications, it's not necessarily a one-to-one mapping, okay? It might actually be affecting multiple features, and we realize that a feature might be affecting multiple needs, right? And vice versa. One need can be affecting multiple features. Normally, this is the case, and a feature would have multiple specifications. But nonetheless, we create this traceability matrix. It's not really part of the course so far, but when we get to the specification, now we're putting in, let's just say, even more of the solution, and we're restricting the design space. So we saw this, that's requirement specification, and I'd say when we did system context modeling and when we did use case modeling, where we actually start to list down the different things that we want the system to do, okay, while talking about the boundary levels, which I said the gray level specifications, okay. Now, I'm not really saying how you should design it from the inside, but nonetheless, I've still restricted you somehow that this is the scenario that I'm expecting, all right. Um, so in requirements analysis and specification, okay, we looked at two techniques so far. We'll be looking at more after the midterm, the first of which is system context modeling, and also use case modeling. And in system context modeling, the idea of it is to understand the context of the system, okay? We need to realize what are the actors that are outside. These actors are going to be involved with us in order to retrieve some features. If we are not even aware that those actors even exist to begin with, then how on earth are we going to figure out what are their needs? You've already done quite a bit of those. Now, let me dive into the details of system context modeling. Okay, as you've done in the quiz, the system itself is a box inside. You got to give it a name. Very important. What is the name? I look for it, right? I give you marks for it as well. The one thing that you for sure could be doing wrong is to call the name of the system itself. Okay, that's not good. And the other thing that is not good is use a verb. You don't use a verb. We're talking about things now, okay? Even the actors outside are still things, okay? They're not actions, they're not verb, okay? So I shouldn't see any of these boxes with a verb in it, like say retrieve weather report, all right? And we said we only care about the direct connections with the system. So if you have another system over here, all right, we're happy to serve you a Starbucks, but the fact that you came to Starbucks through an Uber cab or somebody from your family drove you there, that's really none of our business, okay? And we don't really care about subsystems of those systems that we're going to be dealing with. None of our business. Okay. What we're going to be dealing with actually is what is just an interface. Okay. And also at this point, it's not good to start to specify our own subsystem. This is not the time for it just yet. Okay. Even if those subsystems are talking to each other, all right, we still not care about this relationship that exists between them. It's just the ones that we deal with, right? The entire world is interconnected. Okay. لو هنفتحها مش هنعرف نقفلها, okay, so to speak. If we get started with this, we're never going to end. Okay, so what we're going to do, what we can handle, what we can control is the ones that we're touching immediately. All right. The systems that are outside, usually the trick is two things. It's whether there's a human being involved, and this is just a very generic device. Okay. Unless this generic device, for some reason, is written in the specification that you need to have that for some reason, then we care about the output rather than, sorry, the person behind it rather than the actual device itself. So keyboard and the mouse, all right, unless for some reason there is something specifying, which is usually unlikely, that would specify that you need to give the input through some sort of a keyboard, then it would be rather exact, unlike it. And then the actor, the actual human being, is the one that we care about the most, because we could very well replace a keyboard and a mouse with a touch screen and it would have done the same thing. Okay, just a different technology. and the source is still the same. And even if you look at the output, now if you remember the aquarium example that we did, um, there was a printer. Sorry, we were printing reports. Okay. Now, for that particular example, yeah, it's the printing aspect that is important for the business, and they want to have hard copies. Sure, I'm gonna write a printer then. But if it's just said, I need to show this to the operator, then I don't really have to have specified a printer here anymore. Okay. I would have actually just put the operator as the output. Okay, I would have just put the operator, because then I could decide that I can give it to the operator as the output on the screen or on a printout or maybe even by audio. Different ways I can interact with. Okay, so you got to look at the input and output device and see how business specific it is. Now we've looked also at another example but the buttons. Okay, but threw you a little bit off in that some of the buttons, if it's generic, like the buttons that you see on the side of an ATM machine, those are pretty generic. All right, they're just input mechanisms. Every screen, when it flips over and becomes a different screen, the buttons have a different purpose. Okay. Now, if you have a very, very specific button, like say on a fighter jet, the red button where you fire a missile, or the eject button, then those have very specific. So I can put that onto my diagrams. Um, always a safe bet. Always a safe bet that don't combine things together. Okay, remember the furnace example again. Okay, there's maybe a part of us that says, let's just put them all together. They're all the same thing. They're all the same thing. Be on the safe side and break things down. So when we looked at the buttons thing, they think the oil maintenance button and the water maintenance button. I can't remember what the last one was. The water shield fluid button, right? Keep them a separate button. Okay. If you put an S at the end, this is where you need to rethink what you've just done. Okay. If you say buttons, then you really should be thinking about splitting it down. Okay. So if you find yourself you're using plural for some reason, then you might want to consider, am I really doing this right or wrong? Noura, you had a question. Yes. Actually, in both we have to. Okay. Now, the furnace example is a nasty example. Okay, and I purposely showed you that to give you a taste of what you're gonna get in the real, because you're not gonna get something that is perfect. And us as requirements engineer, this is where we fill in the gaps and we say there's something here that is missing. Okay, or I think there was a different example for that. But uh, in an exam, it's not fair that I'm gonna put you in such a position. So I would give you actually everything that you need in the exam, and if it's not actually in the paragraph, then you really shouldn't actually be there. All right, but I want to leave it open for you to guess in an exam and start to say, oh well, it looks like there's something missing in the requirements engineering. Obviously, we said that when we're doing analysis and design, sorry, analysis and specification, we're looking for the 3 C's. Remember what the 3 C's are? Guys at home, remember what the 3 C's? The first C is? Hmm? No. No, these are quality attributes about the requirements that we get. We want the requirements that we get to make sure that they are, no, correct, good. The other one,
Is consistency one of them?
consistent, good. Last one, no, always concise. A favorite of, for 10 years I've been teaching this course, is concise is the first thing that comes about. Now concise is a style of writing. Okay, it's basically saying what you wanted to say in a paragraph rather than saying it in 10 pages. That's concise. Okay, still that doesn't mean that the 10 pages are wrong. Okay, I'll be rather mad reading the 10 pages for something I could have just read in a paragraph. All right, and the last one is the easiest one. No, cost about requirements in order. Come on, guys. A quality attribute. Huh? See what? يا لهوي.
Comprehensive?
Comprehensive, very close, very close. Huh? Complete, yes. Oh, you said I didn't hear you. I'm sorry. Okay. So if the requirements was A, B, and C, we want to make sure that the C does appear. Okay. Consistent mean they're not saying different things. So if X here is 100, a little later on, somebody said that X is equal to 90. This is inconsistent. And finally, the fact is correct. If somebody says Y is equal to 50 when it was actually equal to 40, then that is just flat out incorrect. Three different aspects. All right. Um, Next up, we looked at use case modeling. Okay, and before we get into the trenches of use case modeling, we said that use case modeling, the only thing that we show is the one of the two types of requirements. We have functional, and the other one's called non-functional. Okay, and requirements engineering only shows functional, they never show non-functional. But before we get into that, what the heck does functional, non-functional mean? What is the difference between functional versus non-functional? Hmm? Turn into code, yes. But it's not just turn into code, okay? Like, more specifically, it's that the meaning of the code and the instruction given by the code to the computer is actually 100% mapping to what their specification was actually saying. So if I wanted to increase the value of x by 1 and I write down x equals x plus 1, the meaning of x equals x plus 1, pretty much in every programming language that ever existed, is I'm instructed the computer to please raise the value of x by 1. Okay, now I happen to have done this in less than 0.05 millisecond, and the requirement said it needs to be done in less than 0.1 millisecond, so we're good. But at the same time, having adhered to that requirement, I didn't actually write a statement that says system dot please do in less than 0.0. So you got to always think of it this way, okay? Always think for yourself the whole thing about system dot something, okay? Now, we said some requirements, okay, at a level, it could be non-functional, okay? Like, for example, being user-friendly. And some, and then I can then later on create more specific requirements, saying مثلا big buttons. Okay, that would be functional. Okay, so I can turn a non-functional into a functional, maybe multiple functionals as well. Yes, yes. All right. Now, big buttons, yes, I can write down something that specifies the size of the button. Yes. All right. But I won't at a level where it just says user friendly, because not very specific. It's very at this level, it's very high. Say system.be user friendly. All right. I know you might be thinking there's no such thing as system.big buttons. Yes, I understand. But yes, you get the idea that you can actually specify the size of the button and so on. Some requirements, they start off as non-functional and they go nowhere. Okay. For example, it has to be in Java. Okay. I cannot create a function requirement out of that. It just stays there. I just got to make sure that on day one of my work, I show up and I make sure that it is Java. Okay. شو حاجة مسوي okay. User friendly. Actually, I wrote it in a quiz before, but yeah. Big buttons, yeah, I can write code for big buttons. The big button, yeah, I mean, we ended up with two requirements. It's just one is non-functional and one is functional. Okay, and that one I've created for a realization of the non-functional, and I'm gonna put my effort when I do the programming to create this, and as it's connected to the user friend, I say, since I've done this, I've basically done that. Now, remember, I just said a moment ago about traceability metrics. Okay, there's a traceability going to be between those. Okay. So if I say I'm going to have those two solutions to have the user friendly, and then decided later on, no, I'm going to cancel this one. Okay. Then later on decide I'm going to cancel that one too. Okay. Then it's a traceability framework or traceability matrix that tells me, okay, since you've canceled the last two, the bottom two, you haven't actually done the top one either. Okay. So careful now. One of the non-functional requirements is is not adhered to. Okay. Usually we get excited. Customers get excited about talking about functional requirements. They tend to not talk much about non-functional requirements, the boring side of the requirements. But nonetheless, non-functional requirements could be as important, sometimes even more important than functional requirements. For example, if you talk about a financial system, a banking system, all right, it could be an excellent, very easy to use, such and such, right? It has amazing features that help you monitor your stocks and whatever and so on. But if that system is insecure, somebody told you that system is insecure, somebody hacked into it, some and so on, you'll be saying, the heck with all these amazing features. Let me go to another system that has a lot less features, but at least that it is secure. Make sure that it is secure. All right. And this is why the fintech, you might hear this term quite a bit. Fintech is financial technical systems. Um, they're really, really uptight about security and control. Okay. And their features had been like the one of the last systems that you actually see with quite a lot of features. Now, the ones that you see nowadays, now that we're 2021, those systems are pretty amazing, right? What you see on your phone and so on. Pretty sure all of you have bank accounts and you have, right? It wasn't like that even 10 years ago. Okay, 10 years ago, you get the most basic functions possible on your phone or even on the internet. And it's because they wanted to make sure that, because this is real money, okay? It's not just even a grade, it's a real money thing, okay? And if so, and it's a number is gone, then that's real money that is actually gone with it as well. All right. And so much so that security was like a 50-step thing, right? You enter username and password, and then they send you a text message, and then somebody calls you, and then somebody shows up at your office and to make sure that it's really you. And it was really, really right. And they had to be. Okay. Now that they've gotten into it and obviously advances in cryptography and network security and all that, now they're more capable to create those features for us. Right. Uh, yeah, yeah, this is exactly what it is. X equals X plus one. I'm telling the system to do it. And it's the meaning of the line, okay? Not a byproduct of the line. Okay? Yeah, no, so it's the storing of the data, that would be a functional thing. Because, huh? Well, here's the thing. Okay, if your requirement is just saying you have to store the data in a database, that's definitely a function requirement. There is code, a lot of code that we write. Something very, very famous that maybe you'll come across in your studies here would be something called JDBC. Okay, Java Database Connectivity. There's a library that you use to make sure that you're able to connect with SQL type of databases. You'll take SQL and databases next year with either Engineer Huda or Dr. Bess, or even with both. But yeah, I write actually code to instruct my system to hit the database and make sure that it's the information stored there. Now, if the requirement is about that the database brand is from Oracle, not IBM, that's not really something that I care about in the code wise. Okay. There's no such thing as data that is non-functional. Data is data. It's neither functional or non-functional. All right. Yeah, yeah. This is actually the question that you got on the quiz. Okay. So the act of storing in itself is functional because I'm gonna write code in my system to say, Mr. System, please go store these data. And this is we do this every day. Every day, all these transactions is all databases hitting and retrieving information from databases. Okay. That's what the entire J2EE enterprise architecture is all about. Okay, and you'll learn a lot more about this when you get to the 310 course, which is with me as well. Okay, but life is all about you seeing an interface, you doing some computation, and then at the end you want to store some information on a database. For example, like your the courses that you're registered in. There's a database that we have here at the university, and all you're doing is you're hitting the database day and night. Okay, when I want to retrieve information about how well you're doing, I want to get your transcript, I read from the database. When you register, it hits on the database as well. And even though, believe it or not, the PDFs that you create, for your transcripts are actually created by reading the database. You get the information, then you create the PDF document with it. Okay, it's not that the transcript is stored. Actually, it is stored, but it gets stored. I mean, this transaction happens once a semester, and then yes, the PDF then it gets stored, and you retrieve the PDF. But the actual creation of the PDF has been done by reading a database. Okay. So that's the first thing that we want to do, is that we want to make sure that we know the difference between functional and non-functional. Okay, so when we go ahead and start to create a use case diagram, we want to make sure that we focus us on the functional requirements. All right, now all we're doing now in use case modeling is where we saw the actors outside, and then we decided to say, what is this actor one? Okay, the actor wants 1, 2, 3, and this is the things that pop up over here. And what we're doing in use case modeling, basically, we're zooming into the system context model, and now we're creating our use cases with the includes and the extends and so on. Okay. And remember, these use cases, they're not design, they're not a solution, right? But saying basically how we want the system to behave, all right, when it's interacting with a particular actor, all right? And then some of these behaviors, some of these services that are being offered to the actors have dependencies on each other. Okay. Okay, so let's take a look at the dependencies here again. So for the dependencies, we said we're going to split them two. We got 4, 2 over here and 2 over there. Okay. First set of cousins is the include and the extend. And the second pair of cousins is the generalization. And the last one is implementation. Okay. Now with the include and the extend, it's an A plus a B. Okay. Not that the include is A and extend is B. It's just, okay. But the important thing is that there's 2 things that are happening. Okay. I'm doing the A and the B. Okay. So, one of the mistakes that I've saw is, remember the donut example thing. And I'm just saying that because something similar happened with the, with the online travel agent thing as well. Okay. But anyway, let me get into that. Okay. Now, if I have something like here, buy donut. Okay. And then I did an extend. And we said the difference between include and extend maybe happens, maybe not. Include always happens. It usually is a big hint of whether it's an include or extend. Okay. So this is why you see with the red, I always put it down as red for include and yellow for the extend. Anyway, and here was apply discount for the donut of the month. Okay. Now I gotta read this as 2 things happening. Okay. First of all, I'm gonna be buying the discount. Buying the donut, and plus the application of the discount. Both of these are gonna happen. Okay. With implementation and generalization, only one is happening. Okay. So with the generalization, there was an A plus a delta. Okay. 1 or 2 things happen, whether it's implementation or generalization. Okay. For generalization, it's an A plus a delta, but actually what happens at the end is either the A or a delta. Not both, exclusive or. Now that you've taken some material from digital logic, I can now speak in that language. Okay. With implementation, it's an A minus plus a delta, what actually happens is the A minus delta, so to speak. Okay, now A on itself, A minus on itself cannot happen because it's a minus. Okay, it's not complete, right? But it's not like there's two, actually there is two things happening. All right, but I'm reading it as there's one thing happening, and basically that before I go ahead and do this, I'm kind of like combining those two together into an A minus delta, that the delta removes the minus at a later point. Okay, with generalization either or happening. Now let's see how this applies. Okay, so this is by donut, and this was what by donut of the month. Okay, now we got A here, and I got the delta. Okay, it's very specific. Now, one of two things is gonna happen. Either the A means I just bought a regular donut, or the A delta, which means I bought the donut of the month. All right. Say what? You're buying a donut, but which one? Okay. Now, when I look at this, I'm not doing two things. Okay. Now, back again to this one. When I look at this, it's not like I'm doing one thing. I'm actually doing two things. Okay. So either approach is fine. It's the mixing and the matching that is not good. Now, what does it mean when I do mix and matching? Okay. So if I went by donut and I went extend by donut of the month, I'll be getting two. Okay. So I'm doing A plus getting the donut of the month. And not only that, okay, I'm silly enough that when I'm the customer over here and I want to buy the donut of the month, the employee tells me, first you got to buy a regular donut, then you're allowed to buy a donut of the month. Okay, so first of all, I got a donut that I didn't want to, and that even donut was actually a regular donut. It wasn't even a donut of the month. Okay, so it's silly. Now I've ended up with two donuts. Okay, a similar situation for this was the buy flight ticket, and the intention here that this was the economy, and then it got extended with buy first class. Okay, that means I'm actually end up with two tickets. All right, and if I'm rich enough to buy a first class ticket, I just made it even harder for you to buy. It's expensive already, but I told you that in order to buy a first class ticket, first of all, you got to buy an empty seat at the back because you're not going to be sitting on two seats at the same time. And you can see how silly this sounds. Now, if I go back over here to this one over here, all right, and I mix and match the relationships here. So I went up and said, buy donut. And this was apply discount. And if I went and I put down here generalization or even had the implementation, all right. Remember, I'm just saying that one is a specific type of other, okay? So even if we do flip the arrow, neither case makes sense, okay? That I'm saying that applying a discount is a specific way of buying a discount, or buying a donut, and buying a donut is a specific way of applying a discount. Neither makes sense. All right, neither makes sense. So it's, you either stick with the extent or you stick with the generalization, the other side of the relationships, but you got to know what you're doing. Okay. Now, when it comes to differentiating between implementation, generalization, you look at the top use case and figure out for yourself if it is complete. Can I do it on its own? You put your hand on the bottom use case and you realize, yes, I can do it. Then it is generalization. I'm talking about when you're differentiating between those two. Okay. If I realize that I can't do it on its own, I have to flesh it out, implement it by one of the other use cases, then, all right. Now, with the generalization and the implementation, let's go here to the side. The general use case goes at the top. The more specific one goes at the bottom. I saw quite a few of you, they flipped the arrow, okay? They had the arrow going this direction when that is wrong, okay? Basically, one of the hints is look at the one with the more text in it, okay? So the one with the less text basically is giving us less information, and that's basically because it's more general. I'm buying a ticket, okay? Buying a ticket on sale. I've given you more information. So just by virtue that I've already used the two words that existed in the general one, sorry, I'm just gonna come to you, right? And I've added more text, I'm being more specific. There's no way I'm gonna add more text to even more general. Usually doesn't happen, okay? So this is a big deal thing. So a lot of you lost half marks on this in the quiz because you had the arrow pointing the wrong direction. You had the arrow pointing to the specific use case when it's supposed to be opposite. Now, look at it this way. What is happening when I'm inheriting, huh? I got 1, 2, 3 here. I got 4 and 5. Oops, 4 and 5 at the bottom. Remember at the end, I said I'm gonna be doing a delta. This was the delta, and this was the A. Now, in order for the bottom use case to get the A, it needs to inherit from the top. So you just notice what I just said? It needs to get from the top, means it's depending on what's on the top, and hence the direction of the arrow is going in this direction. And it's always in general, even with the other relationship is who needs who, okay? Who needs who? What about them? Okay, so first of all, you got to realize to yourself, am I doing an A plus B? Well, an AA delta. Tends to be, one of the hints is that you're reading the same text. If you're reading the same text, no, we're talking about probably generalization implementation here. Okay, if you're reading the same text, okay? But if you're reading two completely different texts, then chances are it's an A plus B. Another way to know, okay? Do a sanity check. Read the two use cases and ask yourself, just create the sentence, formulate the sentence. We had buy donut and apply discount. Can I say apply discount is a specific type of buying a donut? No. Is buying a donut a specific way to apply a discount? No. If it sounds silly, chances are it's not the other second, it's the first one. Yeah, I meant the error. Okay. Yeah, I'll get to that, but I just gotta explain the whole thing in from the beginning, okay? So, all right, so we established that we know that it's an A plus B. Now, first thing you ask yourself, is it an include or an extend? Okay, before we even think about the direction of the arrow. Now, first, if it's happening sometimes, the A plus the B, then it's extend. If it's happening, it has to happen every time. Okay, it's include. Type. Now, the direction of the arrow. Let's think about average and sum. Okay, sum is an A plus B, average is an A plus B over 2. Obviously, I'm grabbing this and I'm putting it over here. You can see the relationship over here. Now, you always read this and say, who needs who? Okay, does the sum actually need to divide by 2? No. Does the average need the sum? Then yes. Okay, now, in general, what it means is, we have a function 1. Okay, think of it functions y, and it's gonna call function 2. Okay, and basically what we do is, this is the code for function 1, and let's just say this is the blue code for function 2. All right, and then when we did the call, we fit it in over here. If this is the case, then it's 1 that actually needs 2. All right, who's calling upon who? If I call you, then I need you. If you're receiving my call, You didn't need me. You know that you want something from me. Right? It's almost like in the real world as well. Somebody's calling, is like, I wonder what he wants from me now. All right. But if you're calling them, you definitely want something from them. All right. So you'll be able to read it this way. And this tends to be, if it's happening always, okay, then it's an include this way. Okay. Now, if it's happening maybe, then this actually doesn't exist. F1 didn't actually need F2, but rather F1 on by its own, without the blue, it could have worked just fine. All right. Meanwhile, F2 is saying, I can, make your operations better. I can add something to you over here. Okay. And so the direction of the arrow when it comes to the maybe, i.e. extend, is pointing in the other direction. Okay. And think of it as your phone and your phone cover. Okay. Your phone could have worked just fine. Didn't need the cover. Okay. So from the perspective of the phone, it doesn't need the cover. Now the cover, on the other hand, it's extending the phone. But not only is it extending the phone, chances are it actually makes no sense without the phone. So if somebody bought you that cover without you actually having that phone to begin with, it would be a very useless. What is horizontal? What exactly do you mean horizontal, ya Naif? Hmm? Oh, the direction of the orientation. Yeah, fine. Yeah, I mean horizontal, vertical. No, horizontal is just a layout issue. Okay, it's there's nothing significant about being horizontal. Yeah. Yeah, of course. Yeah. I mean, if I for some reason, all right, if I for some reason took this over here, if this is what you mean, and I moved it over there, then definitely the direction of the air is going to change. All right, you're taking too much of the quiz here. All right. Now in the real world, you're not drawing one A, B, C. You're drawing a whole diagram together. But like I said, there's too many variations. That's why I like to keep it one line at a time. Plus, it becomes a nightmare for me to mark. The more text that you see in the use case name. Okay. Yeah, well, that's the difference between, that's the difference. In both cases, we know which was the parent use case, which is the child use case. Okay. Now, the difference between generalization and implementation is very simple. Is you put your hand on the bottom one, the child one, you take it out, and you say, can I do the first one by itself? If the answer is I can't, then exactly. And not only that, you have to put it as abstract. You would forget the word abstract. Okay. So when you were sending me the answers for the online travel thing, right, a lot of you were forgetting the abstract. I'm going to get to that in a moment. Now, I remember saying that, if you see those two use cases over here, and it's either generalization implementation, I said that you look at the top one. If it says abstract, then it's implementation. If it's not, but the key thing to this, before we shut our brains and just think about looking at the abstract, is this has to be the second cousins of relationship, okay? To begin with. Now, some of you in the quiz, what you've done, you saw the word abstract, you turned it off, and you put implementation right away. All right? That's not necessarily the case. Okay. Now, let's do something here. Okay. Before I get into that, just make sure we're good. We're good on time. Let's revisit the whole generalization / implementation thing again. Okay. We have a class here called human. We're talking SE 120. Got male, got female. Okay. And we said, if there's something that is going to be common between the male and the female, then I want to raise it up to the human. Okay. So if I have something called eyes, all right, I realize that eyes is applicable to male and female. So I put the eyes at the top. Okay, good. Now, so basically what I'm saying is anything that I'm going to put at the top is going to be inherited into both. Okay, now if this one, think of it this way, I include something, C, class C. Okay, so together, think of this as one unit. And together, all of this is inherited by F and M. Okay, now what that means is not because the thing at the top says abstract, that means that every relationship has to be implementation. Okay, it might be that the abstract is including something, and this inclusion is, I'm doing it at the top level, just like the eyes, because I want to give it to all of my children. Okay, because I want to give it to all of my children. Okay, so if I look at something like mustache, it's only applicable here. All right, think of it in a different way. I have an include, okay, say you're going to call it B, but this inclusion is only applicable to the male, so then I'll keep it at the bottom over here. Now if this inclusion, as I did over here, is applicable to both M and F, then I want to make the include, just like the eyes, be included at the very, very top. All right, now let's remember the online travel agent example thing. So we had, this was by trip, okay, and we extended it with purchase, was it insurance? Okay, this extent got inherited by everyone. Okay, so at the bottom here we said by cruise, and here it was by flight. Okay, this over here, the green, all right, is inherited here and inherited here. Okay, a little later on we said with the flight, I have the economy, by economy, and by first class. The green is inherited here, inherited. So you got inherited all the way from the top and all the way to here. Even in the cruise trip, same thing. We had the regular cruise trip, and then we had the, I think it was the VIP cruise. Okay, still the green inherited all the way down. Okay, I don't need to come over here and I say purchase insurance. I don't need to come over here and say purchase it because I already got it from the way top. If it's something that is applicable to one of the sub levels but not the other one, then I got to keep it at distance. For example, the computing of the nearest port, that's not applicable to flights. That was applicable to cruises. So it wouldn't make sense that I would put it over here. Okay, now I know I said that if this was the case, okay, and this was compute the nearest port, and we said if it's included by one and one only, then I might as well just take this out and shove it back into it. I actually want to see a minimum number of use cases rather than an increased number of use cases. That's actually one of the things you need to watch out when you're creating use case. If I'm just creating bubbles, 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 then this is one of those things that you say, maybe it's too much. All right, maybe I've turned them into functions. Okay, so when you send me your answers, I usually take one look at it and say, all right, I can see a whole bunch of includes that are being included by one. Okay, and like I said before, unless this include is being included by others, then it justifies it being there. Or even if it wasn't included by other, but maybe on its own, I can use it as an actor on its own, then I might want to keep it as an include as such. Okay, and matter of fact, it's necessary in this case that I break it off the base use case. Now, an example of this is if I have a base use case talking about withdrawing of cash, part of what it does, it has to check the balance that you have. Okay, now if the only service that I'm offering is withdraw cash, and I'm not even allowing the person to check their balance for some reason, then I just have the one circle. Okay, now if depositing and all of these things, they require the checking of the balance, a whole bunch of other use cases, then I want to take the check balance out on its own. But sometimes I realize, okay, no, wait a minute, check balance on its own could be a service that is applicable to a user and actually makes sense. If you just want to check your balance, you want to open up your phone, check your balance, you should be able to do that without having to withdraw some money first. Okay.
Sometimes for use cases where they're like include or extend, they may get kind of confusing. You know? So how would you مثلا prepare to say, okay, how can you like be really sure, but if this was an include or extend?
Then you gotta read it and say, first of all, you gotta figure out the dependency and who needs who. But then, as you say, who needs who,
Sometimes it's like
or when we do the A plus the B, do we have to do it every time, or do we have to do it sometimes and sometimes not? Okay, yeah, and I know every time we compute the average, we have to figure out the sum. It's not an option. When we do a transaction, we have to validate the pin. It's not an option. Okay, but if I say I'm going to buy a book, I'm going to give away a T-shirt for it. Okay, that's because there is a promotion. Matter of fact, not only that you realize that sometimes it happens, sometimes it doesn't, you also got to figure out the condition when it happens and when it does not happen. Okay. Now I have a question here on the text. Says, Doctor, when will we write extension points? You should always write extension points. Okay. You should always write extension points. That's the proper way to design your use case diagrams, right? Remember, the base use case doesn't know much about the extension. All right. So it doesn't know when you bring me this gift, so to speak, this piece of furniture, I don't know where to put it in my house. All right. Now, the proper way to do this is say, okay, I'm going to create the base. I don't know what other things are going to be extending me, but nonetheless, here's the place you're going to go ahead and extend. So extension points kind of like the USB, right? Your laptop worked fine without the USB drive, USB port, but it's saying if you want to extend the laptop with other hardware, this is the place. Don't plug it into the screen or plug it into the keyboard. Please plug it into the side where I have the USB port. And the extension points is like this. So it's almost like the analogy of the furniture thing. You kept a place in the house saying, I know I'm going to have some neighbors who are going to be too nice. They want to give me furniture for some reason, but I'm going to dedicate this space for that. When, if they do to be happen to be that nice, this is a place to put the additional furniture. If they didn't bring that additional furniture, will I die? No, I'll do just fine. Thank you very much. Okay. All right, so that's basically what I have noticed as the common mistakes that you've done from the two quizzes and the feedback that I can give you based on that. All right. Then what?
do you mind posting more exercises about it so we can do it? And like we can give us feedback to make it like we can make sure about everything.
Honestly, I don't have a list. It's like I know you're thinking about like a Shams, one of these Shams math books where I can just give you like 600. I honestly don't. It's not like I have. We've covered at least 1, 2, 3, 4. So far 4, and you'll see a fifth one. If I come across something, then you got sources online. I get this question all the time. Even in 310, you'll be asking me this. Can I have more? Yes, the ones that I have, I gave it to you, but there's obviously more online. But as you searching online, I can tell you that there's there's a lot of mistakes that are done online as well. So you got to be careful when you're learning from the online thing as well. So um, but I think, huh?
Can we show it to you like if we saw something?
Of course, yeah, absolutely. All right. Matter of fact, part of my I think at this point there's no point to actually continue the recording because I'm talking about something that's not related to